This is the first video in my series on alternating current. In this video, I'm going to start way back at the first principles, then work through the various aspects of alternating current. You will find this topic, along with others, in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my StanStore at this web address. With AC, or alternating current, it's possible to build electrical generators, motors, and power distribution systems that are far more efficient than DC systems. And so we find AC used predominantly across the world in high power applications. And the diagram in front of you here kind of illustrates the comparison between AC and DC. The circuit on the left is switched to DC, which is indicated by a battery. The yellow dots circulating in a counterclockwise direction are indicating electrons, and the arrows are pointing to the electron flow. We know from our previous study that is the flow of electrons, but convention says the current flow. The adopted conventional current flow is the clockwise direction with the battery. In the case of the circuit on the right, where we've switched to AC and the generator is an AC, or an alternating current generator, you can see the electrons are shifting back and forth, as well as the flow is going back and forth, and that is happening in a 60 hertz system 60 times a second. If a machine is constructed to rotate a magnetic field around a set of stationary wire coils with a turning of the shaft, AC voltage will be produced across the coils of that shaft, in accordance with Faraday's law of electromagnetic induction, which we were introduced in our previous course. This is the basic operating principle of an AC generator. AC generators are sometimes also referred to as alternators. There is an effect of electromagnetism known as mutual inductance, whereby two or more coils of a wire placed so that the changing magnetic field created by one induces a voltage in the other. If we have two mutually inductive coils and we energize one coil with AC, we will create AC voltage in the other coil. When used as such, this device is known as a transformer. The fundamental significance of a transformer is its ability to step voltages down or to step it up from the powered coils to the unpowered coils. The AC voltage induced in an unpowered secondary coil is equal to the AC voltage across the powered or primary coil multiplied by the ratio of the secondary coil turns to the primary coil turns. The transformer's ability to step AC voltages up or down with ease gives AC an advantage unmatched by DC in the realms of power distribution. When transmitting electrical power over long distances, it is far more efficient to do so with stepped up voltages and stepped down currents than step the voltages back down and the current back up for industry and businesses or consumer use. The advantage here is you can use smaller diameter wire for transmission with less resistive power losses. Transformer technology has made long-range electrical power distribution practical. Without the ability to efficiently step voltages up and down, it would be cost prohibitive to construct power systems for anything but close range. As useful as transformers are, they only work with AC, not DC. Because the phenomenon of mutual inductance relies on changing magnetic fields, a direct current DC can only produce steady magnetic fields. Transformers simply will not work with direct current. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also, from time to time, be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned type products. It is also a connection to obtain a free copy of my 24-page three-phase transformer workbook, which will serve as a quick reference and reminder of technical calculations that you may need. This address, of course, is case sensitive. I'll spell it out and make sure that you have it right. Everything up to the first number is lowercase. That is lowercase https://bit.ly/3, then uppercase U, uppercase G, a lowercase j, uppercase B, uppercase I, and lowercase g. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂's products and obtain a free copy of my three-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐂 products. Before I end this video, I want to repeat the connection to obtain a free copy of my 24-page three-phase transformer workbook, which will serve as a quick reference when working on my courses and quizzes. It is also a handy reference and reminder of technical calculations required in your daily job requirements. Finally, here is the link to all of my electrical courses, which are located in my stand store.